Now we are going to consider the chi-square test for checking on the variance. So for this we make use of skippy.stats.chi2.ppf test, and here we check if the sample variance, which is S2, is different from the population variance, which is sigma square, which is given here, sigma square. We also specify the n and the alpha. Now we calculate the chi-square statistic. Now chi-square statistic is calculated by n minus 1 into sample variance divided by the population variance. And here then we calculate chi-square critical value. Now for the chi-square critical value, I need to pass the alpha and degrees of freedom. Now degrees of freedom is given by n minus 1. Here for the two-tailed test we pass alpha by 2, and if it is a one-tailed test I pass 1 minus alpha. So here I get the chi-square statistic and the chi-square critical value. If the chi-square statistic and the chi-square critical, if the chi-square statistic is greater than chi-square critical, I reject the null hypothesis, otherwise I fail to reject the null hypothesis. So here I get, in this particular case, I get the chi-square statistic as 595 and the chi-square critical is 90. 595 greater than 90, as we can see there is a lot of difference in the value. Let me put here this. So here I specify the sample variance and the population variance, and chi-square statistic is 119 and chi-square critical value is 90, indicating that we reject the null hypothesis. Consider if I just pass 20. Here chi-square statistic is 19 and chi-square critical in this case is 8.9, and we reject the null hypothesis. Okay. So here, depending upon the chi-square statistic and chi-square critical value, we decide whether we reject or we fail to reject the null hypothesis. Okay. So let me here let me give 1 minus alpha to check if there is difference between the two values. So here I want to check if one value is less than or than the other value. So this is 5 and this is 25. Here this becomes a one-tailed test, and so it shows me that it has failed to reject the null hypothesis, because one is 5 and another one is 25. One is lesser than the other one. Now let us consider one-way ANOVA. Now one-way ANOVA, it is used to check the statistical differences between the means of two or more groups, for which we use F-statistic. F-statistic is the ratio of the variance between groups to the variance within groups. We have the three groups, and then skippy.stats import F one way, and here I pass in the three groups, and here we see that the values of the three groups are almost similar, and so it fails to reject the null hypothesis that there is a difference in the means of the three groups. So this is one-way ANOVA. Now let us see chi-square test of goodness of fit. Here it is used to determine whether whatever data we have, whether the observed data matches the expected frequency. So here these are the observed value and these are the expected value. That is why the goodness of fit, how good it is fitting with the expected value. Here we make use of stats.chi-square. We pass in the observed and the expected value, and it shows that there is not much difference. It fails to reject. So there is not much difference between the expected and the observed value. So these are the various chi-square tests. Apart from this, what we have included here is, once we calculate the p-value, we are checking with the alpha. That is the level of significance. Another, we can also check what is the critical value. So for z-test, so here norm.ppf 1 minus alpha, this will give us the critical value. Let us say if I am looking for 0.1, then I get 1.282 as the critical value. If I pass in the alpha value as this, then it gives me this as the critical value. That means this is basically allowing a lesser range of error. This is allowing more range of error when compared to 0.01. And if I give 0.1, it allows for further higher range of error. So it's a less stricter form of working. So like this, I can also find out the t critical value by calling t.ppf. Here it takes the confidence level and the degrees of freedom. So whatever is my n minus 1, that will give me the degrees of freedom, and 1 minus alpha will give me the confidence interval. So with that, I can specify the T critical. F statistic, F critical value can also be determined. Similarly, I can also get the chi-square critical value, which we already saw just now. How do I get the chi-square critical value and then compare it for the test purpose?